In this video, we're going to find the limit as x approaches infinity of 2 to the x plus 7 to the x over 3 raised to the 1 over x power. So the first step is to distribute the 1 over x to both the numerator and the denominator. And now I can break this up as two separate limits. So this is the quotient rule of the limit. And since 3 to the x is continuous with respect to x, I can bring this limit as part of the exponent. So what I mean is I can say 3 raised to the limit as x approaches infinity of 1 over x. Now, this limit obviously is 0. So I have 3 to the 0, which is 1. So really what this comes down to is just solving for the numerator, or the top limit. Now, in order to solve for this, I need to use the fact that e to the ln of x is equal to x, and x in this case is going to be this whole thing. So we're going to say limit as x approaches infinity of e to the ln of 2 to the x plus 7 to the x raised to the 1 over x power. And one of the properties of the log is, well, log of x to the n is n times log x. So this exponent will come to the front. But before I do that, actually, because e to the x is continuous, I can take this limit and make it as part of the exponent. Okay, so it's be e to the limit ln of 2 to the x plus 7 to the x raised to the 1 over x power. Now the exponent will come out in front. And I'm just going to rewrite this as x on the denominator. It's kind of implied over here, but I think looking at it in this form is probably easier. So this next step is a little tricky. So first, we're going to need the fact that ln of x plus y is, ln of x plus ln of y is equal to ln of x times y. And I have here is ln of 7 to the x plus ln of 2 over 7 to the x plus 1. And the way I did this was, okay, let's take 2 to the x plus 7 to the x. Let's factor out a 7 to the x. So if I factor out a 7 to the x, that means I have to divide by 7 to the x. Right? If I'm dividing by 7 to the x, these are going to cancel, and that's good. So you have to do that to basically both terms, right? Because I'm multiplying by 7 to the x, and I'm dividing by 7 to the x. So that should cancel out, which is just 7 to the x over 2 over 7 to the x. This step, I just factor out the x and then plus 1. Okay, so this is what basically I'm doing, but here I'm using logs. So that's the same thing as saying ln of 7 to the x plus ln of 2 over 7 to the x plus 1. Because now when I add these logs, I'm multiplying the inside, and I end up with ln of 2 to the x plus 7 to the x. So that was just a little proof how I got that. And the purpose of this is to break it up into two separate limits, because I have this plus here. Now 2 over 7 to the x approaches 0. So ln of 2 over 7 to the x plus 1 approaches ln of 1, which is 0. So this top part goes to 0, the bottom part goes to infinity. So this whole thing goes to 0. Now, this just leads me to solve e to the limit as x approaches infinity of ln of 7 to the x over x. Now we're going to be a little clever and bring the x in front of the natural log as one of the properties. And so the x's are going to cancel. So I have the limit now, e to the limit as x approaches infinity of ln of 7. Well, this is a constant here. So the limit is going to be ln of 7. So I have e to the ln of 7, which is just 7. So my final answer is 7.